Hi, my name is Elena and I am part of the installation and logistics team at East Anglia Offshore Windfarm. Iberdrola is a world leader in wind energy development, and innovation helps us design, develop and deliver increasingly ambitious projects, creating a cleaner energy future for all. Scour is best defined as the erosion of seabed about the base of subsea structures. It happens because the water speeds up as it travels around objects, moving the sediment and creating scour pits like this one. If we do not address the scour problem, it could expose the pile foundation in the seabed and could alter the structural stability of the foundations over time. I've traveled to Offshore to one of the world's largest marine test facilities to learn more about our ongoing research and development into scour prevention and how a system called front mats could protect our wind turbines at sea.
We're here at the Fastlane Facility, one of the world's largest test tanks for offshore scour and sediment transport testing. The tank is 75 metres long, 4 metres wide, and it holds 1 million litres of water, which is the size of an Olympic swimming pool. We take the drawings from Scottish Power, scale them down to 1/25th of field scale. We fabricate the steel jacket in our workshop using welding techniques. We load it out here into the tank, install it on the seabed with piles, fill with water and test.
This is our front mat, which is designed to prevent scour, which is the erosion of the seabed by the movement of water. The fronds are designed on the concept of artificial seaweed, so they reduce the seabed current as it tries to travel through the matted area. This prevents sediment erosion and sediment transportation and protects the subsea asset in the location where the mat is installed.
To do the testing, we bring in 100 tonnes of sand. We install that on the bed of the flume. We then fill with water to the test depth, about 2 metres, and it takes about 2 hours to do that.
So here we are in the control centre of the Fastlane Facility. This is where we crunch all of the data that comes in. So as you can see on our underwater cameras, we have a great view of the structure that's being tested. You can see at the peak of flow where we are now, there's quite a lot of sediment motion, there's quite a lot of sediment moving past the camera. They really give us a great view and an immediate visual feedback on what's going on during testing.
We're simulating strong North Sea tidal currents, both the flood and the ebb of the tide, and on top of that we put large waves to simulate storms and the design event.
So now that the test is finished, we want to analyse the data that we've collected. The levels of the sand in the flume are collected using an underwater laser scanning system. This is the type of data set that the system collects. What we want to do is compare what the levels around the structure of the sand look like before the test to what they look like afterwards, to see how well the front mats have performed during the test.
This testing today is part of our commitment to innovation, research and development of East Anglia One project and the future for offshore wind. We are trialling new technologies that, if they are successful, they could change the way we prevent scour. Hopefully, this video would have given you an idea of the challenges we are facing to bring costs down of offshore wind energy.